So today we're going to be covering, this is actually lesson 8.1, and I'll switch this here. And it's describing distributions, shape, center, and spread. So with that here, I'm going to just switch this to an 8. And we'll get started. So it says distributions. Data are often summarized by graphs. We often refer to the group of data presented in the graph as a distribution. So here in problem 1, it says use the data below to create a dot plot. Then comment on its shape. So a sample was taken of people who are attending a birthday party. The ages of the 10 people in the sample are as follows. Let's see here. So I'm going to make a dot plot, and I will pick, let's just use this purple here. And you can see the first one is that there's 2 people that are 4, right? So I'll put 2 dots for each of those that are 4. And then we had 3 6s, so I'll do a dot for each of those. And then we have 2 7s. An 8, a 15, and a 17. Does that represent the entire data? It says once we have the graph of a distribution, we often want to describe the graph. We generally describe the distribution by commenting on its shape, its spread, and its center. I skipped center, didn't I? So to describe shape, we generally use symmetric, skewed left, or skewed right. And so you can see here I have some basic pictures here for symmetric, skewed left, skewed right. Symmetric just means that you usually have something that's at the center, and you have a nice rise and coming back down, right? Get the idea? So skewed right, it's almost like it's being pulled to the right, so it's getting kind of thinner. So you're going to see a peak on the left side, and then it's kind of pulled longer on the right. That makes sense? Where skewed left means it's going to be bigger on the right side and pulled to the left. So it kind of pulls out that way. Does that make sense? So it says describe the shape of the data in exercise 1. So if I come up here, I didn't leave any space for that, but taking a look at this data, what does it look like to you? It looks like it peaks right here, right? And it comes out this way. Skewed right, okay, because you see on the left side it looks like it peaks quickly and then is pulled to the right. So skewed right, I would agree with that. Now, to describe center, we calculate the mean, the median, and the mode. Though we rarely use the mode, do you guys remember mean, median, and mode? I'm going to put it mean. I think I'm going to use blue. So mean, right, this is the arithmetic average. So usually in elementary school, you find the average of a set of numbers, right? You add them all up and divide by the number of numbers, right? Median, do you remember what the median is? It's the middle number. So you arrange the numbers in order, and you find the one that's in the middle. Okay, and if there's two middle numbers, then you average the two middle. Okay. Sometimes there's one number, and so that would be the median. But if there's two middle, then you average those two. Okay, and then the mode you can think of as the most frequent. So if we're going to calculate the mean, median, and mode for the data that we just had up at the top, okay, for the mean, we're just going to add all those numbers together. So let me just pull up my chart here. So that would be 4 plus 4 plus 6 plus 6 plus 6 plus 7 plus 7 plus 8 plus 15 plus 17, and then all of that divided by how many numbers there are. Well, I see, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So I'm going to divide that by 10. When I add those numbers together, I'm just going to tell you that's 80 divided by 10. So my average is 8. I'll put it over here. And we usually do the X with a hat, right? The X with the bar on top to show that that's the mean or the arithmetic average. Okay, are we okay for that one? Let's take a look here. Median, I'm actually going to do the work for the median back up here where we have the list of numbers. If we have 10 pieces of data, right? Sorry. So we have 10, I'll call it pieces of data. So since it's an even number, it's going to be two middle numbers, right? So we're going to, you could take one away from each side, right, until you find the middle. And it would be those two. Or you can say 10 divided by 2 is 5, right? So go into the fifth piece of number, right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? That's the pieces of data. And I will take the middle two, which would be 5 and 6. So the median is going to be equal to 6 plus 7 divided by 2. That's 13 divided by 2, which is 6.5. Are you guys okay with that? So I'll come up here and I'll say for the work, I'll just say C above. And so I'll put 6.5 here. Are we doing okay? And then for the mode, that's the most frequent. So the chart's the easiest, right? The dot plot that we just made. Looking at the dot plot, what's the most frequent number? Or you can look at the list, the number that occurs most in the list. Yeah, 6. It's the tallest structure right here, right? And so that's going to be the most frequent. And we're good with that. How do the mean and the median in our data set compare? right? The mean and the median. So take a look at the mean and the median. The median was 6.5. The mean was 8. So isn't the mean greater than the median? Right? So I'm going to say here, so the mean is greater than the median. So, and then here, and what I'll write here, I'll just say it's let's put this in this color. So this is generally true when data is skewed right. Sorry, I'm gonna. Hmm. Now, take a minute and think about this. This is actually a really good question. I'm going to put it here. I'm going to write really small. So you don't have to necessarily write this question. How would the data let's say changing the last number from 17 to 27 affect the mean? So let's come down here. Let's come back up here. So if I changed this number here, instead of being 17, we made it 27, right? Which means we get rid of the dot here and we put it way off here, right? 27. How is that going to affect the mean? Right, remember, to find the mean, you're going to add all the numbers together and divide by 10, right? Because there's 10 numbers. So what's going to happen to the mean if I change the 17 to a 27? Okay, the student said that it's going to pull the number further to the right, which would mean that it would make the number larger. Does everyone agree with that? Okay. How about if I change this question just a little bit, instead of ending it with the mean, say if I changed it from 17 to 27, how would it affect the median? So let's come up here. And if I changed the 17 to 27, which removes this here and puts a dot way over here, 27, how's that going to affect the median? If I'm replacing a number, right, it's not going to change the median, right? Unless it happens to be one of the middle two numbers, right? But it's not one of the middle two numbers. We're just replacing the biggest number with an even bigger number. Okay, so let's just, I'm gonna draw. So I'll answer this question right here. I'll just say makes mean larger. And then here, I'll just say here that it wouldn't change. Okay, are we good with that? Spread. Describe the spread. We will calculate the standard deviation or range, right? So to describe it, we're going to calculate the standard deviation or the range. So the range is the difference between the largest number and the smallest number, okay, in the data set. Let me highlight that because I think that will be good to know. So the range is the difference. Actually, let's do this one. So it's the max value minus the min value. I think that's a good way to do it. So in this data set, the range is, okay, so we're going to have to figure out, well, what is the greatest number and what is the smallest number? What was the greatest number in this value, in this list? 17. What's the smallest? Of course, I'll come down here. So the range is going to be 17 minus 4, which is 13. So I can say that the range is 13. Okay, that's just a very physical, tangible number, right? So we use standard deviation to measure the variability among the numbers in the data set. The larger the standard deviation, the more variability there is, right? So it just says how the data set relates one piece to another, okay? So it has to do generally with how far things are from the average. Okay, so the mean, sorry to say that. So for number 5, it says interpretation of the standard deviation. So it says here, the standard deviation of a set of numbers tells us the distance between a typical number. So I'm going to write typical here. Okay, in the set and the mean. So it's between the typical, any typical number in the set and the mean. So notation. The notation for standard deviation of a sample is S, just a lowercase s. The notation for the standard deviation of a population is, they use this sigma. The sigma here, it's like an O with a hat on it. For this lesson, we're going to rely on technology to calculate the standard deviation, but I'll teach you how to do standard deviation. We'll review it if you have already learned it in a future lesson. So, in order to do this, we're going to do it today. We're going to use Desmos, okay, for statistics. So, using the directions on the handout to input each data set, determine the mean, the median, and the standard deviation for each set of data. Then interpret what the standard deviation is telling us about the data. Okay, so I'm going to do this with you guys right now. So I'm just going to switch to my other station and put on the screen here so that you can see. The data set. So I am here. So, and in order to do this, I'm going to go, there's a plus sign, see here in the upper left, right below the black bar, title bar. I'm going to click here, and then I'm going to create a table. So I have X1, Y1. I'm just going to enter the values that we had there, right, for data set 1. So the numbers that you see there are 6, and then I hit enter, 7, 10, enter, 11, and then finally 26. Okay, now you can actually, if I go to the keyboard, right, and I can go to functions here, and then I can click on all these statistic functions, right? We need mean, median, and then we're going to use standard deviation, right? The one without the P. And so, but I actually have it memorized. I can actually just type it, so that's what I'm going to do. So I'll just say, I want to find the mean of, and then I type x1, and that gives me for that data set. So do you see that the mean is 12? Right, it says it right here in that lower left. And we're also supposed to find, was it the median of x1, which is 10. And then the standard deviation, STDEV, is the abbreviation, and x1, and you can see it's about 8.09. Okay, so I'm going to take that data here, and I can, there we go. And I can write it onto my iPad here, so let me do that. So for that first set of data, we have that the mean was 12, median was 10, and the standard deviation was 8.09. Okay. Are we okay with that? Okay, now I'm not going to delete what I have there, but what I will do is I'll come up to my table and I'll delete these. And let's see here. Bump this over just a little bit to get my next data set. And so you can see here it's 8, 10, 14, and 16. And if I just scroll up here, you can see that the mean and the median, right? The mean was 12. The median was the same, 12. And the standard deviation this time was 3.65. Are we okay with that one? Now, did you notice the data, see how the number was smaller this time? We have 3.65 for the standard deviation as opposed to 8.09. So the data is more tightly together when you have a smaller number. And you can see this goes from, the data set 2 goes from 8 to 16. Well, you can see that the range alone there is 8, right? But the basic difference from the mean, remember, it's the typical, it's the distance between a typical data number and the mean, right? And so if the mean is 12, it says that most numbers are plus or minus that 3.6 or 3.7, right? So 12 plus 3.7, that's about 15.7, right? And you can see that captures, most of it. If I subtract, I just subtract about 4 just for the sake of ease is 8. And if I add 4, right, it's 16. So you can see the numbers fall between 8 and 16. Okay, whereas opposed this 8.09 means that from the mean, most of the numbers fall between adding 8.09 and subtracting 8.09. So adding basically 8 and subtracting 8, right, would put me at between 4 and 20. You can see most of the data falls between that. Okay, not all of the data falls between it, right? Because there's typical data there's data that's not so typical, like the 26. Okay, and let's just go ahead and wrap up the last one here. So I'm going to come over here. I'll just type over, so this one's 4, 4. This was our data from the first one, wasn't it? Exercise set 1. 7, 8, 15, and 17. Okay, and let's scroll down here, and you can see that the mean was 8, right, which is what we said, right? And the median was 6.5, that's what we calculated. And then the standard deviation is 4.42. So most of the people invited to the party were about what, between 3.5 and 12.5, right? 4.42 is a fairly small number, so we can see a lot of the people invited were very close in age. Okay, are we good with that? Okay, I'm going to put this over here. And remember, we're going to teach you review calculating standard deviation here over the next several days. All right, let's look at back at our data from exercise 1, which I have right there up above. How can we interpret the standard deviation? So it says here, a typical age in this group of people, okay, is 4.42 years away from the mean. This means that the majority of the data falls between, right, and I'll put here 3.58, okay, and 12.42. All right, but let's just write a little note here. So it's going to be the mean, right? And then plus or minus the standard deviation. So it's going to be the mean, which in the data set was 8, plus or minus the 4.42. So it's going to be 8 plus 4.42. Let's do minus here. And then the second one will be 8 plus. So that's where I got the 3.58 and the 12.42. Okay. Get an idea? Okay. So then here next it says, what statistics do we use? So if the distribution is symmetric, we'll generally use the mean as our measure of center and the standard deviation as our measure of spread. If the distribution is skewed, we frequently use the median as our measure of center and the range as our measure of spread. Okay, so it says here, a local baseball team, the Manatees, has 12 players, and the batting average for those players are as follows. And we have a list of numbers here, and then it says create a dot plot for their batting averages. So let's come here, and let's put those numbers on. So 0.255, that's going to be here. And then the next one is 260. That's here. The next one is 0.265. That's here. And then we're going to skip up to 0.275. And then there's a second 0.275 and a third 0.275. And then to 0.28, there's 1, 2, 3, there's 4 of them. So now I'll do 1, 2, 3, 4, and then the 0.285 here. Okay, so describe the data. Is it symmetric? Is it going up nicely and then coming back down? Okay. So someone's saying no, and they said it's skewed left. It looks like the peak is happening on the right, and then it kind of pulls to the left, right? So it's skewed left. I would agree with that. So let's come over here, and so it says describe the shape. So I would say skewed left. Then C says find the mean and the median of the data set and which is larger. Okay, do you guys know how to calculate the mean? Can I just, well, here. Can I just tell you the mean for the sake of time? I feel like we know how to find mean, so you guys can practice. This is going to be 0.2745. Wait, before I even find the median, do you guys Oh no, I'll keep moving. Okay, so let's find the median. So the data set is in order. How many pieces of data do we have? Right, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Do you guys see that? So if there's 12 pieces of data, right, divide 12 by, it's even, so there's going to be two middle numbers. So if you divide 12 by 2, that means the 6th and the 7th number are going to be to make up the median. So I can go here, and I already lost the 6th and the 7th number. 1, 2, 3, 4, 5, 6, and 7. So here. Right, those are the two middle numbers. So you can see here that the median is going to equal 0.275 plus 0.280, and then we're going to divide this by 2. Okay, and I'm just going to tell you for the sake of time, that's 0.2775. Okay, and that's what they asked for those two. I am going to write a little note here. Let's see here, I'll do it in this gray, and I'll just say, notice that which one's larger? Yeah, the median is larger. So the median, right, is larger than X bar, right? That's what we see here. And this is generally true when skewed left. It says find the standard deviation of the batting averages using technology. So I'm just going to tell you what the standard deviation is just for the sake of time. Use this, and it is approximately, because I'm going to round, and it's 0.01. So if I interpret the meaning of the standard deviation, right, well, that means that most of the data is going to fall between the average plus or minus the standard deviation. So the average in this case is this 0.2745, and then plus or minus the 0.01. Okay, and then I'll just write the two numbers here because it's pretty straightforward. If I subtract them, that's 0.27. It's 2645, isn't it? And if I add, isn't it 0.2845? I'm going to calculate that standard deviation. In my notes, I have something different. So let's, easy enough to calculate it really quick here. So 0.255 0.260, 0.265, 0.275 times, 0.280 times, and then finally 0.285. Oops, oh, it wasn't writing over. Let me just delete these. So I'm just double checking the standard deviation. Yep, it was 0.001. Okay, so if I want to interpret this here, it just would mean that a typical player has a batting average between those two numbers. So I'll say here a typical player has a batting average between 0.2645 and 0.2845. Okay. Are we okay with that now? Yeah? Okay. Got a few more things here. So then we'll take a look here. It says a paleontologist studies prehistoric life and sometimes works with dinosaur fossils. The histogram below shows the distribution of heights rounded to the nearest centimeter of 660 procompsognathids, right? Otherwise known as compies based on fossil findings. Okay. Okay, so it says describe the shape of the distribution. So if I generally just kind of cover that, right? What shape is that, you guys? Skewed left, skewed right, symmetric. Yeah, it's looking symmetric, isn't it? When it's symmetric, remember we usually use the average, and then we'd use standard deviation. It says here the mean of the distribution of Compi's heights is 33.5. The median is also 33.5. What's the relationship between the mean and the median here? And what we have is that the mean is equal to the median. So, and just as a note, this is generally true. For symmetric data. How could we estimate the mode of this distribution? Remember, mode is the most occurring, so what do you guys think? How would you calculate the mode? The height that most frequently occurs. What was that? Okay, so you're saying that the number would be the same as the mean and the median? I'm sorry, say that one more time for me nice and loud. Okay, the same number that's most frequent. So how do you see that on the histogram? Okay. So how do we tell by looking at the histogram here, right? We're looking at the histogram, right? How do I tell which is the most frequent? This is the heights down here, right? So which height happens the most frequently? Isn't it going to be the tallest bar? And we have two of them, don't we? We have this one here, right? And we have this one here. So what does it look like right, so we're going to look for the tallest bar, right? So in this case, we had two bars that are the exact same. What are the heights represented by those two bars? Isn't it at 33 and 34? So we write both numbers. You don't average them, you literally just write them. It tells us that the standard deviation of the distribution is 2.56, so it says interpret this in context. So we know that most of our data is going to fall, I'll write it up here, x bar plus the standard deviation. So in this case, right, did you notice I'm using, sometimes I use S and sometimes I use P, right? Or I'm sorry, I use the O with a hat. The O with a hat means we have all the data, okay? Then the lowercase s means that we just have a sample of the data, a smaller section of it. We don't have all the heights of the compies, right? We don't have the entire population. So this is plus or minus here. But then up above, when I used it, it was the entire population. So that's why I'm flipping between the two. So in this case, we know that the average, they told us in part B, right? The average is this 33.5. So I have here 33.5 plus or minus that 2.56. So when I subtract them, I'm going to tell you that it's 30.94. And when I add them, I'll tell you that it is 36.06. So the typical height of a compy is between those two numbers. So the typical height of a compy is between 30.94 centimeters, so 31 centimeters, and 36.06 centimeters. Ah. Okay, they're very small. So then we have here in the next page, it says the shape of a distribution tells us the relationship between the mean and the median. So this is going to summarize data that I've already been writing into our notes. And so you can see we have symmetric data here for number 10. So in this case, right, the mean is approximately equal to the median. So I'll write approximately and equal. Okay, and this is similar to the dot plot in exercise 9 above. skewed right, okay, the mean is greater than the median. And this is similar to what we saw in exercise 1. And then for skewed left, it's less than. The mean is less than the median. And we saw that in exercise 8. Okay, let's wrap this up. Notice here, it says, did you know skewed distributions tend to have larger standard deviations than symmetric distributions? Distributions with larger range also tend to have a higher standard deviation. And the mean is generally pulled in the direction of extreme values or outliers. So it is affected by skew. Okay. Down here. The histogram below shows the distribution of the greatest drop in feet of 55 major roller coasters in the United States. How would you describe the shape of the distribution? So it looks like it's doing something like this. So what do you guys, how would you describe the shape? Do you agree, skewed right? So what does that tell me about the mean if it's skewed right? Just out of curiosity, if I come up here, right, skewed right, the mean will be greater than the median, right? So I'll just write a little note here, right? Therefore, the mean will be greater than the median. Right, because it's, remember, skew affects the mean. This looks like an outlier, and this will pull the mean from where it is in the middle further to the right. The median is approximately 120 feet. Is the mean of the maximum drop distribution closest to 90, 120, or 135? Explain your answer. So what would you guys say? Well, we know the mean has to be greater than the median, so we have to get a number that's bigger than 120. Is there a number that's bigger than 120? Yeah, it'd be 135, right? How would I explain that? Right, we know that the data is, because the data is skewed right? We would expect the mean to be greater than the median. So we could say there are extra data points that will pull it to the right? I'll write there. There are very large, right, data points to pull the mean up. Would you use the mean or the median as the measure or center for this distribution? And in this case, we would choose the median. And if you remember, you usually use the median because the data is skewed, right? If it was symmetric, we would use the mean. Which measure of spread would you use for this distribution? And in this case, remember when it's, we use the range, right? Again, because the data is skewed. And the range in this case, you would take the largest, which is the 450, and you would subtract 50, and you can see that the smallest is 50. So the range would be 400. So the drop of the roller coaster would be about 400 feet. Okay. Are we good? Okay. Well, that will wrap up our lesson.